Students, we are going to now begin with operations on whole numbers. This is chapter number 2. In this, first we have the natural numbers. The counting numbers are called the natural numbers, and this begins from 1. Next you have here the whole numbers. All the natural numbers together with 0, they are called the whole numbers. So we can say here the smallest natural number is 1. We don't have any largest natural number, as it's countless. Next we have the whole numbers. The whole numbers begin from 0, and the 0 is the smallest whole number. We don't have any largest whole number. Next we will be doing the representation of the whole number. These whole numbers, how we can represent on the number line. A straight line is drawn like this with arrows on both the sides, and we begin from 0. Just like on the scale you have the numbers 0, 1, 2, 3, 4, 5 and so on. It begins from 0. So this is how we are representing. Equal spacing should be there between two numbers. The distance between the two numbers should be same. Now the main thing we will be discussing about the properties of whole numbers. So we will be discussing about the properties. Regarding the properties of the whole numbers, first of all we have the properties of addition. I will be explaining you the properties of addition in short. So the first of all that we have is the closure property. Now the closure property says the sum of any two whole numbers is always a whole number. For example, I take any whole number. Say I take, say for example, 6 and 2. 6 is a whole number, 2 is a whole number, and what I get after adding it, that is 8. This is also a whole number. This is a whole number. The second number also, it's a whole number, and what you get in the answer, that is also the whole number. So this is what it says in the closure property. Now next we have the commutative law. Number 2 that we are doing is the commutative law. In this law it says the addition of whole numbers is commutative, which means that if I take two numbers, for example, I take very small numbers I'm taking, for example, I say 5 and 2, whatever the sum we get, it will be same, like, this means if I'm adding the two numbers, I'm adding 5 and 2, I get 7. Now next when I add, instead of 5 and 2, I add 2 and 5. It is same. So this is what it says. Addition is, commutative law of addition says that this is what we get. Next we have here the associative law. In the associative law, the addition of the whole numbers is associative, which means, like for example, I'm taking two numbers here. I take, for example, say 1 plus 2 plus 3, and here I again write. Now this law, actually what it says if I add these two numbers first, I get 3, then I add the third number, I get 6. But if instead of adding the first two, I add the last two numbers. Last two numbers, if I add first, I get 5. So means 5, the last two numbers are added first, then I add the first number to it, I get 6. So this means answer we will get same. We are changing the order in which we are adding. Still in addition, it will be, the answer is it's not going to affect, the answer will be same. So this was the associative law of addition. Next we have the existence of additive identity. Now it says, this is now fourth number. What it says in the existence of additive identity, if A we say is a whole number, A, this is any whole number, let me take 6 here for example, and I add 0 to it, or I add 0 first, I write 0 first and then A, the answer will be A. Now if I take an example, I say 6 plus 0 is 0 plus 6, order is changed but doesn't matter, and that is equal to 6. So this means here 0 is called the additive identity. I hope it's clear. Now these are the 4 rules in the properties of addition. Now next we have for subtraction. For subtraction, I would like to explain it by an example here. If you see here for subtraction, under the note you can read these things, okay? The difference of 2 whole numbers is not necessarily a whole number. For example, see, if I subtract, say, 2 minus 5, what do I get? It is minus 3. Okay, we get here, I say this is a whole number. This is again a whole number, but this is not a whole number. This is an integer. So I hope negative integer. So I hope this point is clear. Now after this we are having subtraction of whole numbers is neither commutative. Now just remember what was that commutative law. In the commutative law we were having, I say, just like we were adding the 2 numbers. For example, we say 3 plus 2 is equal to 2 plus 3. We have changed the order, but the answer same. Now let's see in subtraction. I say 3 minus 2, it's 1. Now if I change the order, I say 2 minus 3. So it's not equal. What we are getting here? Minus 1. So that's why we say that the difference of 2 whole numbers is not necessarily a whole number. You can see here it's not a whole number. Similarly, let's check for the subtraction of whole numbers. It says it's neither commutative nor associative. For example, for the commutative, if you see, we have 6 minus 8, for example. 6 minus 8, we get minus 2. But it is not equal. If I change the order, I say 8 minus 6. We get 2 here, and these 2 are not equal. So we can say here it's neither commutative. This we have discussed about the commutative law. So matlab in the subtraction it is not commutative. Now let's check for the associative also. For the associative law, that in difference in subtraction, this law, it's not there. For the associative, for example, I take an example, say, for example, 3 minus 2 minus 1. And then I write, now first I subtract the last 2 and then this. See, this is how I'm putting the brackets. Let's solve it. 3 minus, subtract the 2, we get 1. So 3 minus 1, it's 2. It won't be, actually it's going to be not equal. First let's check. 1. 3 minus 2 is 1, minus 1, 0. So you can say 2 is not equal to 0. So this means associative law, subtraction of whole numbers, is neither commutative nor it is associative. This what we have checked is the associative law. Now next let's do with the properties of multiplication now. Properties of multiplication. Now, first of all, the property that we're going to do is a closure property. It is the closure property. The product of 2 whole numbers is always a whole number. Let's take an example. I say, for example, 5 and 2. These 2 are whole numbers. 5 is a whole number, 2 is a whole number, and answer what we get, that also is a whole number. So this is the closure property of multiplication. Next, we will be doing the commutative law of multiplication. Now, the multiplication of whole numbers, it's again a commutative. For example, if we say, I multiply, say, 5 into 2, and that will be equal to 2 into 5. When you multiply, you get the same answer. So this means this is the commutative law of multiplication. So means multiplication में commutative law works. It is there. Next, we have the associative law of multiplication. In the associative law of multiplication, for example, I take 3 numbers. You will just see how it is the same. 2 into 5 into, say, I write here 6, for example. Now, in this case, I multiply the first 2 numbers. And here I take the last 2. You will just see 5 2s are 10 into 6, 60. And you will see when I multiply this side, it should be 60. 60 means yes, we have the multiplication of whole numbers is associative. 30 multiply, we get 60. So because we are getting the same answer, you can see the means order we have changed. Okay, 3 numbers we are multiplying, we have changed the order. First we have multiplied here the first 2, we get 10, and then we multiply the third number, or we multiply the last 2 numbers and then we multiply the first number, we get same. So this is the associative law of multiplication. Now next we have here the existence of identity. This is the 4th part I'm doing for regarding the properties of multiplication. Next 4th we have the existence of multiplicative identity. So in this we say, for example, we just multiply any number by 1 and we get, or we do it like 1 into 2, we have changed the order, we get 2. So here 1 is the multiplicative identity. Okay, so here 1 is the multiplicative identity. Next we have the multiplicative property of 0. Now we are multiplying, for example, any number I multiply by 0, or I write changing the order also, we get here 0. We get here 0. So this means this is the multiplicative property of 0. Okay. So next we have the another very important law which we have used in the questions also, which we have sent you. That is a distributive law. Distributive law of multiplication. Distributive law of multiplication over addition. Over addition. So what it says, see, for example, I would be taking an example in this. We say 5 into, very small numbers, I'm going to take 1 plus 3. Okay, so if something like this, so we say 5 you first multiply by, because multiply have 5 multiply by 1. Then you have here plus 5 multiply 3. See, I repeat this. 5 multiply, in the bracket we are having 1 plus 3. Okay, so this 5 first we multiply it with 1. Whatever we have in the bracket, 5 we multiply by 1. And then plus this plus here. Okay, 5 multiply 3. So when we solve it, we get 5 plus 15 and we get 20. So this is the distributive law of multiplication over addition. You must have seen in the questions we have done all this. The main thing is you should know how to open the bracket. The main thing is how to open the bracket. Okay, means 5 you multiply by 1 first, फिर plus, then 5 you multiply by the second number. Now next we have here the division on whole numbers. For the division on whole numbers, see, in this case, we will be dealing with the division algorithm. That is, we are very much familiar with this thing. When you are dividing it, here we have the dividend, divisor, quotient, remainder. And we know this, when you put it in the formula, you write dividend, this dividend is equal to divisor into quotient and plus remainder. Okay, and few rules are there. This we already know, that division by 0, we cannot divide by 0, it's meaningless. Okay, and one more thing regarding solving the expressions, we have already done this in 5th standard, that is BODMAS, BODMAS. In our book it's written only this much, DMAS. Brackets are not there. B stands for brackets, O is for off means multiply only, but whenever off is there, that is to be solved first. D we know stands for division, M stands for multiplication, A is for addition, and S for subtraction. So one example I can take here. Regarding the solving, a very simple one. For example, I say here 15 divided by 5 into 4 divided by 2. Now in situation like this where division is at two places, the division which is in the first place will be solved first. See, this is, I'm doing question number 12, 5th part. Okay, your division which is at the first place, that is to be solved first. 15 you divide by 5, you get 3, then into 4, divide by 2. Now next, according to the rule, this is the rule, division first, so matlab this is to be done first.